Swayam Prabha. Digital India. Educated India.
The current value Hamiltonian H bar would be Pt into It minus C into It xt minus rho t into Yt. Okay. So, this is very simple. This is net revenue, but in the context of a non-renewable resource, apart from the cost of extraction, what we said, that since this resource cannot be replicated so easily, apart from this cost of extraction, we need to subtract the opportunity cost of extracting the resource today. Okay? That is what we say. Right. So, now first order condition is, what is the first order condition? Basically differentiating this function with respect to Yt and set it equals to 0, and that implies what you will get, Pt equals to C plus rho t. Okay. This rho t, that means price equals to marginal cost of extraction plus rho t, where rho t is known as shadow price. Shadow price of the resource. So, that means price equals to marginal cost of extraction, what we can write, plus shadow price. Okay. Pt equals to this. Okay. Now, second order necessary condition is basically what we have derived already. What is the second order necessary condition? Rho dot t equals to R into rho t minus del H dot del xt, del H dot del xt, which we have derived earlier. If you go back, I can just show you. This condition, rho dot t equals to R into rho t minus del H bar del xt. Okay. This is the condition. Now, from here what I can write, R into rho t, and this del H bar del xt, if you differentiate this function with respect to xt, so that means x is appearing only here in the C function, what I will get, del H bar, sorry, this I will get del C del xt, because there is no other place where x is appearing, x is only here. Okay. So, this is actually, we can think of del C del x is itself is negative, because this is called stock effect on cost of extraction. So, that means we can write this is basically equals to R into rho t plus del C del xt. Okay. Okay. When when del C del xt equals to 0, what we can get, that rho dot t divided by rho t equals to r. So, that means when there is no stock effect on cost of extraction, shadow price should grow. What is rho dot t divided by rho t? This is basically growth of shadow price. So, when there is no stock effect on cost of extraction, shadow price should grow at the rate of discount. Okay? Shadow price should go at the rate of discount, right. So, this we can write from here. What I can write, that when there is no stock effect on cost of extraction, that means what I am saying, del C dot del xt equals to 0, shadow price should grow at the rate of discount or interest rate. Okay. All right. Now, this condition rho dot t equals to r into rho t, this we need to again examine. So, rho dot t equals to r into rho t plus del C dot del xt. This condition we need to analyze. So, here this del C dot del xt, what we can think of, this is stock effect on cost of extraction. That means, indirectly we can say this is basically marginal benefit of not extracting the resource today. If I do not extract the resource today, then only the stock will be more in the next period and cost of extraction would be less. Very simple. More stock means less cost of extraction. So, this del C dot del xt, then we can think of marginal benefit of not extracting the resource today. Not extracting the resource today. And what is R into rho t? See, rho t, we said this is shadow price. So, that means this is some kind of price of the resource we can think of. Since there is no direct price, we are thinking of the shadow price concept here of the resource. If I extract the resource today and keep the money in bank, then bank will give me some interest. And what would be the total interest gain? R into rho t, because 1 unit of resource, the price is rho t at tth point of time. So, 1 unit of resource, if I extract today, I will get rho t amount of money, and that same rho t amount of money, if I keep it in bank, then bank will give me rate of interest r. So, the total gain from that is r into rho t. So, that means when I am not extracting the resource today, basically I am sacrificing this amount. So, that means we can think of r into rho t is marginal cost marginal cost of not extracting the resource today. Not extracting the resource today. So, this is marginal benefit of not extracting the resource today, and this is marginal cost of not extracting the resource today. At equilibrium, these two things should be equal. Okay, these two things should be equal. So, here what you can write, we can say that this condition we can write as negative also as the original this thing. So, at equilibrium, r into rho t should be del c dot del x t, which implies rho dot t should be 0. Rho dot t should be 0. Now, what is rho dot t? So, rho dot t, when I am saying rho dot t equals to 0, what is the meaning of this? See, rho dot t we can think of change in price. That means, borrowing from the finance literature, we can say that rho dot t is basically capital gain. Okay, capital gain. So, that means at equilibrium capital gain is 0. If there is a capital gain, then the resource owner will always try to reallocate the resource from today to tomorrow. Instead of extracting today, they will extract it tomorrow. So, then there would be some kind of benefit, right. So, this capital gain, that means from this equation rho dot t equals to this, rho dot t, when I am saying rho dot t equals to r into rho t, rho dot t equals to r into rho t minus del c dot del x t. From here what I can write, rho dot t plus del c dot del x t equals to r into rho t. Now, this condition rho dot t, I will write it again in the next page, rho dot t plus del c dot del x t, rho dot t plus del c dot del x t equals to r into rho t. Okay. So, r into rho t is basically total benefit of extracting the resource today. How? Because if I extract the resource, rho T is the money what I will get, I will keep it in bank, bank will give me an interest at the rate R. That is the reason R into rho T is basically total benefit of extracting the resource today, right. Now, total future benefit if the resource is not extracted today is basically a summation of, if I keep the resource for tomorrow's use, what will happen? Tomorrow there will be more stock and that will give me an impact on the cost of extraction, which is called stock effect on cost of extraction. So, I will get this benefit, stock effect on cost of extraction, which is denoted by del C del x t plus there would be another benefit. If I do not extract the resource today and keep it for tomorrow, there would be another benefit. What is the benefit? Tomorrow we may expect that price of the resource will increase. So, that is called capital gain. So, this is basically gain from higher price. Capital gain, and that is denoted by rho dot T. So, that means at equilibrium what is happening, today's benefit is actually equals to tomorrow or future benefit. Today's benefit is this is today's benefit, given by R into rho T, and tomorrow's benefit is actually summation of these two benefits, stock effect on cost of extraction and capital gain denoted by rho dot T. So, this is a very simple rule that we have derived from the cost of extraction of a non-renewable resource. We have derived the price condition. So, that means if we go back to the optimization problem, we said that this is the risk, we have a stock of resource for which Yt is basically the rate of extraction, price is Pt. So, there is instantaneous some revenue if we extract 1 unit of resource, that would be Pt into Yt, and cost of extraction C, which is basically a function of rate of extraction and the stock. We assume the cost of extraction positively related with the rate of extraction, that is why del C del Yt is greater than 0, while del C del Xt is less than equals to 0, and net revenue is Pt Yt minus C function Yt into Xt. An objective of the resource owner is basically to maximize this benefit over a period of time, that is why integration 0 to T Pt Yt minus this. Okay. And optimization basically requires two steps to be involved. First of all, setting up current value Hamiltonian H bar, and then we need to, like any other standard optimization, differentiating the current value Hamiltonian with respect to your decision variable Yt and set it equals to 0. If we do so, if we follow these two steps, so first step what we did, basically we set up the Hamiltonian. And how do we Hamiltonian? This is simply net revenue minus opportunity cost of extracting the resource today. Rho t into IT amount we have subtracted, and rho t is basically we call shadow price of the resource. So, if you differentiate first order condition, we will get price equals to marginal cost of extraction plus the shadow price. Over and above the marginal cost of extraction, something should be added, we have discussed initially, and we said that that is equals to basically user cost, whatever you can think of, and everything taken together, this is called augmented marginal cost. Marginal cost is basically augmented by an user cost, and the user cost or shadow price, these are all similar concept. Earlier what we defined as user cost, here in this context I am saying it shadow price. So, marginal cost of extraction plus the shadow price, that is what we got from this condition in the context of a non-renewable resources. Since it is not easily replicable, optimum price should be determined by this rule, where price equals to marginal cost of extraction plus the shadow price, and this shadow price concept is equivalent to marginal user cost MUC, and taken together this you can think of augmented marginal cost. Augmented marginal cost. And the second order condition we have already derived earlier, rho dot t equals to r into rho t minus this. So, that means we need to differentiate that this function current value Hamiltonian with respect to x, and if you do so, x is appearing only here in the cost function. So, that is why rho dot t minus this. Since this is negative, we made it positive, you can keep it as it is. And we said that when this is actually 0, del c dot del x t equals to 0, then shadow price should actually grow at the rate of discount. Very simple, okay? Because if you do not keep the resource, then there would be a capital gain, price would be changed, and what is the rate of change of price, rho dot t minus this, and over time at least that price should grow with the rate of interest. Otherwise, what is my incentive to preserve the resource? So, rho dot t minus rho t, the change in price should be at least equals to r, that is what we say. And from there we derive rho dot t equals to r into rho t minus this. This you can conveniently keep positive or negative. If I keep it negative, then also it will become positive because this is negative. So, at equilibrium these two are actually this equals to this, r into rho t equals to this. What is del c del x t? This is basically stock effect on cost of extraction, which is nothing but marginal benefit. That means, if I do not extract the resource today, keep it for tomorrow, only I am going to realize this stock effect on cost of extraction due to higher stock. So, that means that is marginal benefit of not extracting that today. But if you do not extract the resource today, there is a cost also. What is the cost? You will lose some amount of interest which you could have earned by extracting the resource today and keep the money in bank. And what is that amount? R into rho t. That is why marginal cost of not extracting the resource today. At equilibrium these two are equal, and that makes rho dot t equals to 0. So, that means the resource owner is indifferent when there is no capital gain, okay? There is no capital gain. So, this condition rho dot t equals to this, then later on we say that basically what we derive, this condition rho dot t plus del c dot del x t equals to r into rho t, basically it tells us that at equilibrium today's benefit of extracting the resource should be equals to tomorrow's benefit if it is not extracted today. So, today's benefit is r into rho t, because I will extract the resource, get rho t amount of money, keep it in bank, bank will give me interest at r. So, r into rho t is today's benefit, and total future benefit if I do not extract the resource today is basically two components. Firstly, I will have some stock effect which is given by del c dot del x t, and I will have some capital gain. So, that is what we learned from today's discussion. Thank you.